Hello everyone, welcome to my second vlog in DBMS. In this video, topic what is normalization. First is, let us define normalization. Normalization is a database design technique which organizes tables in a manner that reduces redundancy and dependency of data. It divides larger tables to smaller tables and links them using relationship. So trivia. The inventor of the relational model, Edgar Codd, proposed the theory of normalization with the introduction of first normal form, and he continued to extend theory with second and third normal form. Later, he joined with Rayford F. Boyce to develop the theory of Boyce called normal form. Moving on. There are three normal forms in normalization. First is each table cell should contain a single value. Each record needs to be unique. Like for example, there is a brand name and a product, price and its product code. Let us define first what is keys. A key is a value used to identify a record in a table uniquely. A key could be a single column or combination of multiple columns. Note, columns in a table that are not used to identify a record uniquely are called non-key columns. What is a primary column? A primary is a single column used to identify a database record uniquely. It has following attributes. A primary key cannot be null. A primary key value must be unique. The primary key value should rarely be changed. The primary key must be given a value when a new record is inserted. What is a composite key? A composite key is a primary key composed of multiple columns used to identify a record uniquely. In our database, we have two foods with the same brand named Nestle, but they have different names. Like this, for example. In the brand name, there is Nestle, who has a product of Pringles. And they also have a brand name called Nestle, who have also a Crunch product. So let's move into second normal form. Second normal form rows will be, row number 1 will be in one normal form. The second row, single column primary key. It is clear that we can't move forward to make our simple database in second normalization form unless we partition the table above. Like this, for example. In table 1, we have product 1, we have product ID 1, 1, 2, 3. We have also brand name Nestle, Jack and Jill, Life Good, and its products are Pringles, Crunch, Chippy, and Nova. In table 2, we specify its product and its price, where product 1 have a price of 100 and the product ID 2 have price of 75. In table 2, product ID is the foreign key. Foreign key reference helps you connect your tables. A foreign key can have a different name from its primary key. It ensures rows in one table have corresponding rows in another. Unlike the primary key, they do not have a unique, most often aren't. Foreign keys can be null even though primary keys cannot. The third normal forms rule. First rule will be in two normal forms, and rule number 2 has no transitive functional dependencies. What is transitive functional dependencies? A transitive functional dependencies is when changing a non-key column might cause any of the other non-key columns to change. Like for example, in table 1, we have product ID 1, 1, 2, and 2. We also have a brand name Nestle, Jack and Jill, Life Good. We have also products such as Pringles, Crunch, Chippy, and Nova. We also have a product code ID 1, 2, 3, and 4. In Table 2, there is a product ID and a price, and also in Table 3, the product code and the product code ID and the product code. We have grain divided our tables and created a new table which stores product code. There are no transitive dependencies, and hence our table is in 3 normal form. In Table 3, product code ID is a primary key, and in Table 1, product ID is a foreign key to primary in Table 3. So now our little example at a level cannot further be decomposed to obtain higher forms of normalization. In fact, it is already in higher normalization forms. Separate efforts for moving into next levels of normalizing data are normally needed in complex database. And it will end our discussion for this topic.